We've all experienced an accident or made a mistake before. We're only human, right? As an IT support specialist, it's important that you're prepared for a disastrous accident or mistake. Maybe an electrical surge fried the hard drive in a database server, or someone deleted the wrong folder. These things happen, and you need to be prepared for them. This is where the disaster recovery plan comes in. A disaster recovery plan is a collection of documented procedures and plans on how to react and handle an emergency or disaster scenario from the operational perspective. This includes things that should be done before, during, and after a disaster. The goal of the disaster recovery plan is to minimize disruption to business and IT operations by keeping downtime of systems to a minimum and preventing significant data loss. Despite the name, a disaster recovery plan will actually cover preventive measures and detection measures on top of the post-disaster recovery approach. Preventive measures cover any procedures or systems in place that will proactively minimize the impact of a disaster. This includes things like regular backups and redundant systems, anything that's done before an actual disaster that's able to reduce the overall downtime of the event is considered preventative. For example, it's standard for critical network infrastructure or service to have redundant power supplies. They're often fed from different power sources like battery backup. This is designed to minimize the downtime that would be caused by one power supply failing or a power outage. That would be a preventative measure. We'll go into some more detail on this in the next lesson when we cover designing an effective disaster recovery plan. Detection measures are meant to alert you and your team that a disaster has occurred that can impact operations. Obviously, you need to be aware of a disaster in order to take appropriate steps to reduce the impact on your organization. Timely notification of a disaster is critical since some steps of the disaster recovery plan might be time sensitive to ensure there's no data loss or equipment damage. If there's a power outage, for example, critical systems should fall back to battery power. But battery backup power will only keep the systems online for so long. To avoid potential data loss or damage, these systems should be gracefully shut down before they completely lose power. This is why lots of systems that support redundant power supplies also have a function to send alerts on power loss events. Other things that should be monitored to help head off any unexpected disasters include environmental conditions inside server or networking rooms. Flood sensors can alert you to water coming into the server room. Temperature and humidity sensors can watch for dangerously high temperatures or suboptimal moisture levels in the air. This can alert you to failed cooling in the server room. Smoke detectors and fire alarms are also critically important. Remember that it isn't just the technology that's necessary for a business to continue to operate. You also need the people working there. The specifics of building evacuation usually fall to the building management team, but as an IT support specialist, you will likely work closely with some members of this team on things like power delivery, heating and cooling systems, and building evacuation. If there's a fire and the building needs to be evacuated, you should be prepared to set up temporary accommodations so people can still work effectively. This might be as simple as sending everyone home for the day and having them work from home, but you should be prepared for the situation ahead of time and have a plan in place to ensure that everyone is able to work from home effectively. Finally, corrective or recovery measures are those enacted after a disaster has occurred. These measures involve steps like restoring lost data from backups or rebuilding and reconfiguring systems that were damaged. Once the disaster has been detected and steps have been taken to either prevent an outage or at least minimize downtime, work should begin on restoring full operations of everything affected. Usually, a disaster will take out one system that's part of a redundant pair or a replication scheme, which would prevent a complete service outage. But that would mean you aren't prepared for another disaster. When one system in a redundant pair suffers a failure, it's called a single point of failure. This is because it only takes one failure now to completely take the system down. That's not a scenario you want to be in. We've covered the overall elements of a disaster recovery plan. Why don't you take a little break to recover yourself, then join me in the next video. We're going to run down the details of designing a disaster recovery plan of your own. Does that include planning for the zombie apocalypse? You'll have to watch to find out. So what exactly goes into an effective disaster recovery plan? Well, it depends. Keep in mind, there's no one-size-fits-all for disaster recovery plans. The mechanisms chosen and procedures put in place will depend a lot on the specifics of your organization and environment. But we can start by covering the 3 types of measures in more detail. We'll also go over some examples to help give you an idea of what to think about. A good way to understand what to plan for is to perform a risk assessment. This involves taking a long, hard look at the operations and characteristics of your teams. A risk assessment allows you to prioritize certain aspects of the organizations that are more at risk if there's an unforeseen event. Risk assessment can involve brainstorming hypothetical scenarios and analyzing these events to understand how they'd impact the organization and operations. When you look into preventive measures, pay attention to systems that lack redundancy. If it's something critical to permit operations, it should probably have a redundant spare, just in case. Make sure you have a sound backup and a recovery system along with a good strategy in place. Ideally, you should have regular automated backups to backup systems located both on-site and off-site. It's also critical that you have data recovery procedures clearly documented and kept up to date. Data recovery following a disaster is hopefully something you will rarely do. It's important to make sure that these procedures are updated since systems change and evolve throughout their lifetime. Redundancies shouldn't be limited only to systems. Anything critical to operations should be made redundant whenever possible. This includes power delivery or supply, communication systems, data links, and hardware. Think through the impacts that a disaster affecting each of these aspects would have on your day-to-day operations. What would happen to your network if the building lost power? Can your users continue to work if the fiber optic data line for the building gets damaged by a nearby construction work? Your core router for the office just burst into flames. Okay, the last one is a little far-fetched, but I think you get where I'm going. Another super important preventive measure that should be evaluated and verified is operational documentation. Make sure that every important operational procedure is documented and accessible. This includes things like setting up and configuring critical systems and infrastructure. Any steps or specific configuration details that are needed to restore 100% functionality to core systems and services should be documented in detail. It's also important that this documentation is kept up to date. An effective way to do this is periodically verify that the steps documented actually work. You don't want to find yourself in a situation where you need to reconfigure a system following an incident only to discover that the documentation is wrong. When looking at detection measures, you'll want to make sure you have a comprehensive system in place that can quickly detect and alert you to service outages or abnormal environmental conditions. If uptime and availability is important for your organization, you'll likely have 2 internet connections, a primary and a secondary. You'll want to monitor the connection status of both of these links. Ideally, they should be configured to automatically fail over if one goes down, but you'll still want to be alerted when this happens so you can investigate why the link went down and work on getting it back as soon as possible. The way to think about designing detection measures is to evaluate what's most critical to the day-to-day functioning of the organization. What infrastructure services and access are absolutely vital? Those are the ones you should be closely monitoring. And it's not just outages or complete failures you should be watching for. Of course, you'll want to monitor for those, but you also want to monitor for conditions that indicate that a problem is likely to occur. If we can avoid a catastrophic failure by being alerted to an overheating server before it fails, that would be much better, wouldn't it? So you want to monitor conditions of service and infrastructure equipment, things like temperature, CPU load, and network load. For a service, monitoring for error rates and requests per second will give you insight into the performance of a system. You should investigate any unusual spikes or unexpected increases. These early warning systems allow you to head off disaster before it brings operations to a halt. And of course, you absolutely must test these systems. Simulate the conditions your monitoring systems are designed to catch. Make sure the detection thresholds actually fire the alerts like they're supposed to. This testing goes beyond just the monitoring systems too. You'll also want to test your reactions and responses to these alerts. If your monitoring systems reliably trigger alerts but everyone just ignores them, they aren't super useful, are they? You want to conduct regular disaster tests to make sure systems are functioning and that your procedures to handle them are also up to the task. Corrective or recovery measures include actions that are taken to restore normal operations and to recover from an incident or outage. This includes steps like restoring a corrupted database from a backup or rebuilding and reconfiguring a server. Your disaster plan should include reference or links to documentation for these types of tasks, anything and everything that would be required to restore normal operations following some disaster. This is where the steps for restoring various systems and data from backups should be. The disaster recovery doc doesn't need to contain the details of the operations. Links and references are sufficient, but it's important to be prepared for a situation where typical documentation access methods are unavailable. Let's imagine you keep all your operational documentation in a wiki on a dedicated server. What happens when that server suffers an outage? It's important that critical documentation is accessible if an emergency scenario or disaster strikes. In the next lesson, we'll cover what to do after a failure. See you there.